First up, we'd like to introduce you to Mr. Rob Stevens. Rob is no stranger to the mining community. He's a strategic thought leader and innovator in the mining and materials industries, and I've known Rob for almost a decade and had no idea he holds a PhD in nanotechnology. He's got 30 years of progressive leadership, culminating the last 6 years as Director of Applied Research and Technology for Teck Resources. He recently left Teck and continues to work at the nexus of technology, innovation, and strategy, focusing on comminution, heavy lift airships, and materials technologies. Rob, you have both the microphone and control of the presentation. The floor is yours.
Thanks, Cal. So I'm presuming everyone can see my screen just fine. And thanks, Cal, for the introduction. Good morning to everyone from the land of Be Calm, Be Kind, and Be Safe, otherwise known as British Columbia. So I'm very privileged this morning to be providing you with an update on what I think is an exciting technology, an exciting project from both the new innovation perspective itself, but also from a mining industry innovation ecosystem perspective. And as you'll see later in the presentation, I'm representing a committed and talented team today. It's likely that many of you are unclear what exactly this CAHM platform technology is, so we'll start at a high level and dive in from there. Is it going to run? Okay, the current best practice from an energy perspective is a gyratory crusher, followed by an HPGR circuit and a ball mill. However, HPGR technology only gives about a 30% energy savings compared with a conventional SAG mill, so it's only justified for harder ores. The original CAHM technology was invented to replace HPGR or SAG circuits. The Monoroll concept was also invented by Larry Nordell when he was challenged to figure out how to find a potentially lower cost method for validating the original CAHM technology. And the consortium members quickly identified the approach as being a potential replacement for a ball mill, and that would then give a simpler comminution circuit of a gyratory crusher, CAHM, and Monoroll to produce feed for downstream mineral separation circuits. So the conjugated Anvil hammer mill platform consists of two closely related technologies. They consist of a hammer rotating inside an anvil, and the mechanism that we're looking for is thin bed breakage mechanism. So when Klaus Schonert did his original work on how to lower the cost of or the energy consumed in comminution, it all came down to keeping a very thin bed of particles. So think of throwing a rock into a pile of sand. All of the energy is absorbed by the sand bed and nothing breaks. But if you throw the rock onto a layer of sand that's very thin on another rock, then particles start to break. And in the case of the ported variant, if you're introducing shear breakage as material moves through the pocket, you're actually putting the rock in a combination of tension and compression, and tension has much lower energy to break rocks. So from here on, when I speak about the just CAHM without anything else, I'm referring to the ported variant. And over here, we also see the Monoroll variant, which would retrofit into an existing ball mill or rod mill. Essentially, we take a large single rod and put proprietary liners on that rod and also on the roll and on the shell, and that becomes our crushing surface as materials move down, or grinding surface as material move down the mill. It moves multiple times under the hammer roll to break. Why the CAHM platform? Well, we see a number of benefits and impacts coming from the performance goals we've set. And here, the ported and the Monoroll versions. And assuming we're successful, those benefits and impacts will actually align with CEMEX's mission of reducing mining's footprint by more than 50% by 2027. The The primary goal has always been energy efficiency, and discrete element method modeling simulations are predicting up to 3 times reduction in energy consumption per unit mass at the same particle size. We've also set a goal of high reduction ratios for simplifying circuits and thus reducing CapEx, OpEx, and dust emissions potential. Where is still a great unknown. And although we're using DEM modeling to forecast wear and tweak liner designs accordingly, the proof is really in the pudding and can only be truly answered at the next phase of the technology development cycle, when variants are able to run for long enough to see what the wear looks like over the longer term. The last 2 goals provide some interesting benefits. Test work by others suggests that dry grinding can give up to a 2% flotation recovery improvement, while we expect a sharper particle size distribution from the Monoroll to result in several benefits and associated positive outputs or impacts. Innovation is fundamentally a people-centric process. We're advancing all of the legs of the innovation stool, but the people leg is bigger for a reason. We have a great team who have come together to work in a collaborative manner on this platform technology project. As Henry Ford said, coming together is a beginning, keeping together is progress, and working together is success. And to put that another way, the team has been through the forming, storming, and norming phases and is now in the performing phase. Like all teams who work together over a period of time, some people leave and some people join. We thank Hatch for their contributions to the project and look forward to working with them again on future projects. We also welcome Vale to the project. Companies are also bringing in more people to the team as well. CTTI has stepped up to fill some of the key gaps. CAHM are adding to their team to support the project, and key experts in the various sponsoring companies are participating in ongoing roles. We'd also like to acknowledge the help of Andrew from NCED Business School on helping us understand the marketing aspects of the technologies. And of course, none of this would be possible without money and in-kind resources. So the team would like to acknowledge the contributions of all of the partners to this project. The first adopters are Agnico Eagle, Glencore, Kinross, Newmont, Teck, and now Vale. CTTI is also contributing significant in-kind resources, as is CAHM and CMIC. Last but not least, as you'll see on the next slide, Natural Resources Canada, as part of the federal government, is contributing significant cash through the Clean Growth Program and through the Crush It Challenge, and we acknowledge their support. The Quebec government is also contributing through the Quebec Innov program. So one of the key barriers to advancing comminution technologies is the scale at which you need to test. And that means the associated cost is high. Just thinking about some of the mining technologies that are, for underground mining that we just saw, they're pretty expensive investments for people to make. And also, up to now, development work has been particularly on comminution, has been largely a suck and see approach, with little in the way of computer modeling to really guide the development teams. As you see from the pie chart, the technology platform project overall budget is approximately 6.5 million. Approximately half of that is cash and half of it is in kind. A key enabler for this project has been extensive DEM modeling. CTTI has assembled the most extensive DEM simulation capabilities for mining and minerals processing based on Larry Nordell's 20 years plus of experience with DEM and building teams to develop and exploit DEM codes. The codes include particle breakage and wear models that allow us to simulate the comminution processes and make predictions of the machine performance. So we've completed hundreds of simulations so far as part of the project to explore various aspects of the machine design that would otherwise have to be experimented with in a physical suck and see methodology at much higher cost and time expense. The DEM modeling is suggesting that the CAHM should be 3 times more efficient than the comparable HPGR pilot unit, more than 2 times the reduction ratio. There's also suggesting that the machine can be run in different modes depending on the site objectives. We're seeing similar sorts of energy reduction forecast for the Monoroll as well. In terms of go-to-market strategies, our next step for CAHM would be to find a mine where we can test the prototype's wear performance and long-term operating behavior. For perspective, each 3-ton test lot at CAHM will be processed in a few minutes, and that's just not enough time, aggregate time, to actually understand the wear. But it is long enough to test the energy consumption and reduction ratios and some of the other parameters that we want to look at. When we start thinking about the size of the machine, it would have a capacity in an operating environment of more than 1,000 tons per day, which is actually enough to debottleneck a small operating mine. And for the Monoroll, we would also be looking for a ball mill and operating mill to retrofit and test for longer durations. So where are we at? Well, we're into detailed design of the CAHM and preparing for fabrication and machining to actually build the machine. On the right, you can see a photograph of the completed hammer roll for the Monoroll at Maritime Hydraulics in New Brunswick. The shell of the CAHM ball mill shown in the middle picture is being replaced, and fabrication is underway at Maritime Hydraulics. And liner manufacturing for the Monoroll is commenced at Nobel Precision Tool in Toronto. Nobel will also do the final assembly before the hammer roll is shipped to General Foundry in Montreal for lead filling, and all of the other parts are shipped to CAHM for final assembly. One question that we do get asked is, what's the impact of COVID? And at present, we're managing to work around those impacts. We're experiencing some delays in various phases, and we have also been unable to meet in person for extended planning and project review meetings, as well as site meetings to inspect equipment. But we have been able so far to stay approximately on schedule as we find workarounds. We also managed to have all of the baseline testing done ahead of CAHM shutting down. So as noted, we've completed the baseline testing. Agnico Eagle has provided over 100 tons of ore from one of their operating mines for baseline testing and preparation for testing of the CAHM and the Monoroll technologies. One of the key advantages of working with CAHM is access to their pilot scale comminution technologies to provide scale to scale comparison. Here we can see both the pilot HPGR and the ball mill that we're using for benchmarking. And as noted, we will actually replace this shell and use custom designed liners fitted into that shell. Before we finish, I would like to spend some time reflecting on the bigger picture benefits of this project. The mining industry innovation ecosystem continues to evolve, and not necessarily in the best way possible. Budgets are getting tighter, companies are consolidating and or gyrating in their innovation strategies. And the need for innovation, as Gord noted at the beginning of the AGM, is continuing to grow given the lower grade, deeper deposits that we're finding, and particularly increased societal expectations. So it's expensive to do hardware-based innovations in the mining industry, and the market is still fairly small. Open innovation approaches are one way to address these challenges, but the number of successful instances are few in the mining industry, and thus we really don't know how to play well together. What you heard from Mal is that really is changing in the surface mining space, and it's changing in the processing and energy space as well. This project is demonstrating one approach to open innovation, and innovation happens at the speed of trust. So we can say that this project is building trust at multiple levels. I count the people in the team from the various companies as friends now, so we've worked together for so long. Companies are also having conversations that did not happen previously at various levels of the organizations. And the ecosystem is being expanded and more partners being drawn in through participation in the project. The project is also critical for CMEC. 3 key words for CMEC are connect, catalyze, and transform, as you've already seen from Mal. And this project falls into the transform area where we're looking to transform the comminution space. It also forms part of the portfolio of approaches to contribute towards zero mining, as coined by CMIC. At an operational level, we're developing and improving the CMIC systems and processes to deliver platform projects. It's something that we probably should not underestimate. Actually getting the fleet of company lawyers to agree on documents, for example, can take a long time, and I think we've got some good templates that we can draw on now. We're also validating the DEM modeling approaches that can be used for reducing the cost and risk of developing new comminution machines, as well as improving existing comminution equipment. And an example of that would be the application of DEM modeling to SAG liners, SAG mill liners, where we think that we can get up to a 20% improvement in comminution performance at lower wear rates compared with existing liner designs. There are many people and organizations to acknowledge. First, I'd like to acknowledge the great team and our vendors who are working with us to keep the project on track. I'd also like to thank the companies for their contributions to the project, and we've listed them previously. I personally have supported the CMIC vision and mission since for over a decade now, and I'm really happy to see this project actually moving ahead. Last but not least, I do want to acknowledge the support of the federal government in particular for the Crush It Challenge and Clean Growth Program funding, and the Quebec government for their cash contributions. And we're looking forward to crushing it with this platform project, and I'd be pleased to answer any questions that you might have before we move to the next presentation.
That's awesome, Rob. Thank you very much.